So, good afternoon. I wanted to finish up chapter 2, and we started right here on this slide. And this slide gives you the most dangerous malware attacks to date. So you can look and see variations of this list, but if you take a look, at this one is the 10 most dangerous viruses ever. This list is very similar to that PowerPoint. This one was created in 2004. So one of the things you want to do, sometimes I put most destructive, and use let's put malware. And do you see that one's 2006? It has a date on it, and it's a older date. Then go to another one. And Wikipedia actually has a really good look at the timeline of viruses and malware. So, like I was saying, a lot of times they're just all lumped into one thing, rather than which one of them are worms, which one of them are viruses, those. But it tells you right there, if it's a virus, a worm, a Trojan horse, whatever it is, a memory resistant. So sometimes, like I was saying in the video just earlier on this one, sometimes you're just going to have to wipe your system totally out and start over. Now, when you take it to shop, there are tests that they run to scan for viruses and those kinds of things if your computer is shut down. Do you see that some of them are unknown, how many systems they infected? Some of them are based on actual numbers. Some of them are percentage. Some of them are still going on, as you can see with corn flicker. It's unknown, the financial damage, and Microsoft still has the thing. So, interesting. And if you have a Mac machine and you think viruses are not written for Mac machines, you're wrong. Not as many as Windows, of course, but they are. There is a virus, and I was trying to remember what it was called, something that had the number 36 in it, that was designed just to attack flash or jump drives. So, and of course, I always ask you to buy one of those if you have class in the classrooms to take your work with you. But the topic still doesn't come to me. So a virus arrives. It's activated when the software or the attachment is opened. It does what it's going to do. And remember that there is a difference. Like worms just keeps repeating themselves till they fill up your hard drive. That's a very typical thing for a worm to do. On my home machine, I have it partitioned, like I do here. You learn that in software support, how to partition your hard drive. So that here I have all of my software loaded on C, and D is where I save my files. And you can see I'm almost full there. But I got a worm on my D drive, came in on a file attachment, and it at home. And it just replicated till it filled up my D. So I believe in creating a backup of your system, and then you'll be able to restore it. Some of them are designed to elude detection. Now, the malware that I was telling you that I have on one machine at home, my virus protection don't pick it up, even though it has a new updated virus protection fix. It still doesn't pick it up. So gaining access, the back doors gaining access to a network or a system with a newly discovered way. So we've got malware, which includes viruses, worms, Trojan horses. We have then backdoor attacks, denial of service. And usually those are sent to the target web server just here. And I know some of you are really new to computers in this class. Like this is my first semester at college. Some of you are skilled in computers, but just bear with me as we go through. When you, if you are new, you might want to check out the things that are that you can do on your system, the backup and recovery and all that stuff that you're going to learn in the classes. The denial of service is usually done by an email attack to a particular IP address until the system crashes. Denial of service, again, a stream of coordinated requests. Distributed denial of service, or just a denial of service. The hacker compromises a system. It uses the computer, but it uses it takes over a system, a computer, and then uses that computer to compromise other computers. So, yeah, it's usually coordinated. Mail bombing, DOS, so they've differentiated the denial of service with a mail bombing DOS, and usually it's email that overwhelms the servers. We access a lot of different servers in a day's time as students and teachers. You know that there are dedicated email servers. There are dedicated web servers. Every web page you see on the internet is housed on a web server. So and then there's database servers. Generally speaking, the web page, like Amazon, is not on the same server as the database that it writes your purchase to. So the file servers and all of those kinds of things, we use a lot of different servers, and whether or not, most of the time they are, their client, server, which means that someone, the administrator of that server, has to set you up with an email address, or a user ID and a password. Napster made peer-to-peer, possible, where no node, N-O-D-E, that's every machine, printer, router, whatever it is that's on a network, no node can function right on that server. So anyway, going forward, you hear me say the term server a lot, and there's basically two types of server configurations, and that is client server, where you enter a user ID, password, or some other kind of entry, and then peer-to-peer, where nobody is the administrator of the server. Every node is on the same level, much like the dark web is put together, where no node is, all of the resources are available to everyone. Okay. Spam, we know what that is. Packet sniffer. I have my email open. And today, this is just today, and we have a good IT department. Just today, I have received 18 spam emails. And you can see they run from lamp companies, to, hygiene products or glamour products, insurance, let me make you rich kind of schemes, weight loss, lending institutions. Well, actually, some of them were. I thought I cleaned them up on last Thursday when I left here. So spam, we'll get a lot of it. Packet sniffer, that monitors the data traveling over a network, and that can be legitimate, that you want to look at the traffic on a network. They can also be looking for information to steal. Spoofing is to gain access that assumes a real, generally a genuine IP address. So it's giving us a look here now. If you're new and you're going to learn, I hope most of you that are really new this semester are also enrolled in the Introduction to Networking class. You may not be, but it teaches you a lot in that class. This is a version 4 IP address where, the country and it's a geographical location of that IP address. And now we have version 6 that allows us to have a lot more connections to the internet than the ones we had. We frankly ran out. These numbers can go from 0 to 256, so there's actually a lot of them. But we have version 6 now that IANA is using when they do new IP addresses. So the hacker modifies the address to some kind of spoof server IP address. So the firewire allows it in, thinking it's legitimate, and then it takes over. So software attacks, farming attacks the browser's address bar to redirect users. And I think probably if you've been using the internet for a while, you know that, right? Then the man in the middle, the attacker, monitors the networks, modifies them, sends them out as if they were legitimate. So giving you a pictorial of what actually happens when somebody intercepts. Now there's a key there showing you that most of the encryption, and that's the word, and we've all used it. In grammar school, I remember very well setting up a little scheme that if somebody in their notes drew a heart, it represented the actual heart, or an A is an asterisk and a B is this. And so we all encrypted, and we had some kind of guide to go by to unencrypt it, and that's really how encryption works. There's also public keys and private keys, and that's why there's a key right there to show you that they use that concept in encryption packages. Technical hardware, when the manufacturer themselves distributes equipment with a flaw, kind of like our government distributed Obama's health care, knowing they knew it was flawed, they knew it was not ready. But I think the pressure to have it by a certain date caused it to go live even when it was obvious that very first day that it wasn't ready. So they gave them an additional month. It seems to me that sometimes there's nobody in charge in our government these days. Bad statement. I'm not political, not teaching politics, but in a couple of cases I felt like there was nobody in charge or nobody overseeing certain people in our government today. So you have a unreliable service or no service at all. Some errors are terminal, some are not. The CPU can fail. Yeah, it can. In hardware support, you will learn how to troubleshoot computers and listen to the beeps that they make. You'll learn how to spot common things like what happens if RAM fails, or what does the computer do when the CPU fails. A lot of times it's because that computer has gotten too hot, or the power supply is going bad, or there is a battery that's in there. Maybe the battery's bad. To me, that's the hardest thing to do, is to troubleshoot. But it is, if you want to do the A+, some of you will probably just tick with that. So what is the mean time between failures of hardware? One of the things that I tell students in the intro classes like 130 and 146, I see most people using their laptops flat down on their beds where it can get no air. The breathing holes are on the bottom most of the time in laptops. So if you're that person, then that motherboard's going to get really hot, and it'll shut it down. It'll cause the CPU to fail. It'll sometimes just short it out, cause other things to fail. Technical software failures, large quantities are written, debugged, and published and sold before all the bugs are detected and resolved. And of course you know that. That's what happens with service packs. When you look at your system, it tells you what your operating system is and what service pack you're using. And that's exactly what it is when a service pack is issued or a new revision is issued. It's trying to generally to address things that there's holes in it, or maybe some service packs, now I shouldn't say that all, some revisions actually add to the functionality, but most time it's a cleanup of code. Combination of software and hardware can reveal new software bugs. And one of the things, if you're writing software for a particular system or platform like Windows, then it would be written differently if you were going to include platforms like the Linux or environment, things like that. So most of the time, you're going to have to download a separate piece of software for the different platforms. If it's 32 or 64-bit, as in mine is a 32-bit operating system. Most of the instructor machines in the lab now are 64-bit, so you'll have to have a different type of, a different version of the software in those cases. Websites, yes, entire websites dedicated to documenting bugs. And if you want to look out there, there's one out there for Windows 10. I personally have enjoyed Windows 10. I hated 7, going from Windows 7 to Windows 8. I hated it. I don't know what happened to 9, but 10's out, and I like it. I like it a lot more than I did 8. Open Web Application Security is dedicated to create trustworthy software. I'm going to go ahead and end right there. And I wanted to see that in front of you. When I was reviewing, I thought I needed to start making myself a list, because there are certain things in there that I want to share while I'm actually doing the video. Open Web Application Security Project. That might be something, if you are a cybersecurity student, that you spend more time with. It is not the same thing as W3C that just specializes in software. This is the security of that software. So that was pretty interesting in this portion, is to be able to see that. And I'm going to put that link right there, upload it again as we go. Deadly sins in software security, and so buffer overruns. When you took C++, if you have not yet, when you take C++, make sure that your teacher talks about arrays. Arrays is the ability with a programming language to use one variable name for multiple values, and each value is put in like a list and starts numbering at 0 and goes to however many they are. When you run that program, it is supposed to tell you and alert you that you have used more than you said you were going to. Say if you initialize the array with 10 data values and there was really 20, it takes up more RAM. And so that's a buffer overrun. It has a channel or a container that's supposed to hold just exactly what you told it would. And then if it's an overrun, it doesn't. Command injection, cross-site scripting. I hate it. Now, one of the things that happens, and I'm going to do a video, this is your browser. When you know that, when you load a web page, there are third-party cookies, third parties that is not on that web page, not the web page you visited, but it is trying to to see what you're doing. They're called third-party cookies. The site that you visited does know they exist and allowed them to try to sell you stuff. So cross-site scripting is just that. It's trying to send code across websites when you're there buying something or doing different things. Softwares at our level, when we're teaching programming, we don't teach how to cross-site script. We don't teach how to add commands that were not there to begin with. We do teach how to handle errors. In most of those softwares, we don't get to the networking stage to do anything with handling traffic. We do talk about storage and hopefully how to protect your data. We really don't do any encrypting. We just show you how to do the basic code. Now, I'm going to put this in my C++ class this semester because last semester we created in my class a cash register. So we used variables to ask the user for three prices. We added them up. We put tax on there. We give them a total cash register receipt. We fixed it so we could give them a discount if they bought over a certain amount. Using all of those programming structures, ifs and loops and all of those things. So one of my students did not want to print the date. He wanted the date to be put in there when the program ran, no matter if it ran today or next week. And that's the printf function. And you see that it does have problems. C does not, in its core libraries, give you a way to print today's date. There's a lot of people out there that have created code to do that. I've been teaching C for years now, and C just doesn't do it. Applications that use dates to do a lot of different things, and I opened Excel to show you that, if it finally will. Change control, other things. Now, let me just show you. When you do dates, where did it go? It kind of jumped on me. I don't know. Today's date, right? So now just look at that real close. So if I type in today's date, can't tell I'm already a little tired this morning. Usually it comes right up and finishes typing it for you. Okay, today's date, and it's just a format the way it actually looks, whether it's a long date or a short date. They look exactly the same, right? But on this one, every time you open that document, it's going to modify that date to now. If you type in a date, it's going to put the date that you had on there when you did it in. So that's what I was trying to show you with the printf function. Sometimes programmers do not code or document their programs well enough so that when updates are needed, maybe one block of code is linked, or has a function call or a function definition and changes it one place and don't change it in the other, stuff like that. Improper file access. You know, I hope you know from your C++ programming class, and those of you that are not there, that you'll get it as soon as you can. That class is offered every semester. I show you how to read from and write to external files. So there's lots of things that can go on there. You know, your operating system uses lots of different files in the installation of software and those kinds of things, like log files or DAT files or INI files. How a programmer could shut down that network really easy is to overwrite those log files. I mean, it's easy as pie to do if they don't know what they're doing, or if they do it maliciously. Either one, it really doesn't matter. The damage is done. The secure socket layer of networking, that's what that entails. Information linkage, is that coming from within the company? I've had lots of education and communication type classes. I promise you, something happened at this college right before the semester started, and I heard it from outside the college from two sources before inside the college knew it. I'm serious, it happens. Integer bugs, overflows and underflows. Yeah, there you go. Math and math operations. I don't know what that is. I looked at it and I read it, but I've got to refresh what that is. I go through the chapter before I record the videos so that uh, I don't try to repeat what the book says. I just try to summarize it. And so I've got to look again at what race conditions are. Let me pause just for a second. I had to reread it. A race condition is, when you create a external file to write to with your say your C++ program. Well, the race condition is when a program creates that temp file and an attacker replaces it between the time it's created and the time it's used. So a lot of things going on there. SNL injection when the developers fail to validate, and we've talked about that in the web classes over and over again. Only certain people within the organization should be able to change data in a database, not the average user. Deadly sins in software security again, trusting network, address solution, authenticated key exchange, magic URLs and hidden forms. A lot of things going on now that just wasn't there when I first started to teach the web. I got to look at what they're calling. This has to do with the URLs, of course. But what happens is sometimes, and you can see it, the URL, there are something called a meta tag that can direct you from one web page to the other. The HTTP can be replaced with just www so that it's not secure. Do I need to do that real quick? Do you see this site? This is my SNEED, and I've logged out. Do you see my SNEED is HTTPS? That means it's a secure site. You don't see www there, and you want on any of them. I'm just doing a lot of work. Now, do you see there's a www, which means that it is available to the World Wide Web or to everybody. If it's HTTPS with no www, that that it's a client server. It's a secure network. I wanted to look at this also as I was going back in my book and looking at what that was. They give us in the book the top 10, the OWASP, or however they want to say that, the Open Web Application Security Project, publishes a list of the 10 most critical web application security risks. So as I was looking at all these things on the PowerPoint, I decided there's that stock overflow. I wanted to go back and look at the top 10. I don't see a direct link. Right there it is, right at the top. That's your top 10 security risk. This is the most recent. And so you've got a PDF. There's, if you want, let's see, this is probably the English one. It's kind of neat. They put it out in a lot of the major languages. When I went to Brazil working on my dissertation, and there were language translators then, but they sure have improved since then. I went 3 different times in the early 2002, 2003. The last trip was in 2006, and the people in Brazil would tell me that the language translators, although they could read it, was not really good, and that's really taking a long time to download. And let's look here if that'll just take us straight to, I thought that would take us straight to Wikipedia. That would just give us, without having to wait forever. There we go. And I need to put this is their top 10 injection. Remember that SQL is a programming language for relational databases and other things there that they inject into. Broken authentication, cross-scripting, insecure direct references, security misconfiguration, sensitive data, missing functions, or that is, functions are a programming structure that puts the task in one place and the call to that task in another place. So let me put this in our PowerPoint as well as we're going. Okay, so there's our top 10. Technical, outdated infrastructure. IT plays a large role. That's an understatement, but you can understand that if a company has a certain server, and we've talked about this in database class, if they have that, all of their resources set up on Windows 2008 server, for example, it is a big deal to put a new server in place and transfer all of those resources to a new server. So you can see sometimes how a company will use an infrastructure for a long time before they actually change over. If it works, a lot of times they don't change it unless they have to. Theft, we don't have to talk about theft. Secure software development, and there's a lifestyle of software development. Software assurance, there's actually learning programming is relatively easy. It really is. And that's why I think we have so many problems, because it's easy, but then the advanced things like how do you clean up RAM when your program's quits running? C doesn't automatically do that for you. And if you run the same program over and over and over and over and over, even though we have lots amount of RAMs, maybe you add some variables or different things. You can eat it up really quick. So, secure software development is, I don't know, sometimes if they should just let everybody, all of us, teach software. What we do here is we teach entry-level classes, and there's no way we can cover all of those advanced concepts, but we do try to tell you in those classes, be sure not to do this, don't do that, and then we rely on you not to do those things. A software assurance common body of knowledge. So the Department of Defense and other organizations are trying to do recommended guides, and that is something that I have never incorporated into my classes. I've just done what I've learned over the years. So I might have to start adding this to my curriculum. I told students today, I said, teaching this class has added a new scope. Now, I've always been concerned with security, but I've never actually taught our first, or one of our first, cybersecurity classes to give you the foundation that you need for cybersecurity. software design, keep it as simple and small as you can. But if you can imagine how many different pieces of code did it use to create an operating system? Thousands, right? And in that thousands, there can be numerous different programming languages, tapping the strength of each language, right? So, small and simple, yes, but sometimes we're building huge developments. Um, the access to those things, the system administrator sets them up. That says by permission and not exclusion. So think about the people in the organization and why that's important. Every object is checked that they have the authority. The design depends on the keys or the passwords, right? Protection that requires two keys to unlock the cryptonology of that. Um, Now, do you see that programs and users only have the necessary privileges? When you set up a user on a server, you decide if they can read the things on that server and read only and not write to, not have permission to change or delete. So the basic rights on any server is read, add, change, or delete. And so the system administrator sets up the privileges for every user on that system. This is the way the databases are set up. You can assign roles, and then in that roles, set the privileges that you want that role to have, and then you put people in the roles. You don't do it in the reverse order. You set that up at the beginning. The human interface in C++, we create a text-based interface so that they have, say, 4 choices and they can choose 1, 2, 3, and 4. If they key in something besides 1, 2, 3, and 4, then there's a statement that says, in this case, then do this. Okay, maybe close it or say, you didn't select one of the choices. In Visual Basic, we try to teach is to create that project so the user never has to guess what they should do. This last semester, and I know I've got a zillion things open, I always do before I get to any one particular thing. Let me see if I still have it here. I created, the last time I taught VB, I created a slot machine as my final project in that class. And I was just, oh, here it is, Lucky Spin. Is there any confusion on what you should do if you want to spin it, right? Right, spin it if you want to stop it. That's the only 2 choices you have. So that's a really small example, but users should be able to determine what they should do on any given time. So that's chapter 2, and I hope you will spend this lot of information in this chapter. And there's some things in that chapter that's not on the PowerPoint. For example, there's a mean time between failures equation. There's that, if you are a server administrator or a database administrator or an IT person, that would be one of your critiques as if your job was doing well or not. Before we leave, I can easily find one of those files that we created with C++, a file that we created, a programming language, see, that we wrote to that file. And I'm just going to go ahead and right-click it and open it with Notepad, even though I wouldn't have to. It has a Notepad extension. There's one. Stephen's furniture, a chair, table, a bed, that the amount. And he didn't do a whole lot of, formatting, but you can see the basic thing. This is one of the files that we created a cash register receipt, and we wanted to write it out to a file so that we could actually print that cash register receipt if we wanted to, because every time we people buy something, we get one. So uh, the programmer can name that file anything they want to name it. If a programmer should look on your system and say, oh, I think I'll overwrite that log file, and that log file actually runs or has a connection to run an application or even the network itself, they can screw you up pretty quick. Okay, that's it. Chapter 2. Have a good rest of the day.